Hello and welcome to our second video of our math review, this time on optimization, focusing on the concept of trade-offs. Let's begin. Trade-offs is the basic concept of optimization for us. It's actually the most important concept because the key to understand why a certain decision is optimal for the agent that's taking it, be it a firm or a consumer or the government, is to understand the trade-offs involved in making that decision. This is in fact the same concept you've been seeing since your first econ class, and it's a concept that's going to come again and again, regardless of whether you're taking a class in game theory, a class in macroeconomics, a class in firm behavior or industrial organization. All of these classes are going to have in common that you're going to have agents that are making decisions and trading off the benefits and costs of those decisions. And identifying the trade-offs is generally very simple and something we shouldn't overlook. The fact that it's easy to do actually means that this has a lot of value for us. It's something that we can do quickly, but it's something that's going to inform us for how we should tackle the problem. And so the first thing you do is, what do I gain if I increase x? From our previous video, we remember x is like this standard value for a variable that you're choosing. So an example is, why do I get with more consumption? So you always have to think, if I move this, if I increase this variable, what am I getting in return? And then think, what do I lose if I increase it? Perhaps you're losing something. So if you increase more consumption, you might be winning extra utility. If you hire more labor, you have to pay those costs in wages. Okay, always ask what the trade-off is before taking derivatives. Derivatives are very useful for us, but they're not always the answer. But the trade-offs are always there. Whether you can take derivatives or not, you're still facing trade-offs. And so you do want to know exactly what the problem of the agent is before you attack it, before you try to solve it. As you will find out, many exam questions are designed exactly to catch these cases where the student doesn't really understand what the trade-off is. And so you might face problems where taking derivatives is of no use, but just thinking about the trade-off and understanding how the agent is making decisions, that's going to give you the key to how to solve the problem. Okay, with that out of the way, one thing to understand about trade-offs, and this is going to be the case typically, but not always, is that the trade-off you face changes as you consider different options. As you increase consumption or hire more labor, the trade-off is going to change. Let's go through some examples of what I mean by this. As you consume more, the benefit in extra utility from more consumption diminishes. So you're getting satiated. And so it might be that the cost of that additional consumption does not change, but the utility that you're going to get out of that extra consumption might be changing. And so understanding how your trade-off is being modified as you consume more is going to help you understand when and why you get to an optimum. Other two examples are hiring more labor. It might be that the productivity of additional workers it's lower the more workers you have, so that the benefit of more workers is also going to diminish. But the change can also be in the cost. Perhaps you are exerting effort to search for jobs, and the more you search, the more costly it is to exert even more effort. And so that's also going to play a role in deciding how hard should you search for a job. We're going to be going back to these type of questions much later on in the course when we talk about unemployment. Now, the key here is, of course, to balance the costs and benefits of making a decision, to balance how much do you get out of increasing the value of x versus how much do you lose? What's the cost of increasing the value of x? And so we're going to find it very useful to do the following. Every time you take a derivative, you should be able to both express it and interpret it as equating the marginal cost of making a decision with the marginal benefit of making a decision. We know from the previous video that as you equate these two, you get to an optimum. The reason is that what you're doing here is you are guaranteeing that as you increase the value of the variable, if the marginal cost is equal to the marginal benefit, then your overall value that you're getting, it holds steady. And that's the definition of a critical point, or a first order condition when you equate to zero. And so we're going to be going over this interpretation in terms of marginal cost and marginal benefit in our next video. But for now, let's take a simple example that we can do very quickly. And this is the example of maximizing profits, where you want to have a profit function that's going to depend on production output, that depends on capital and labor. Capital is going to be fixed, and we're only going to choose labor, which we have to hire at some constant wage rate of W. Okay, what do I get if I increase labor? More production. Output is going to increase. So that one's easy. And the cost is also easy. What do I lose if I increase labor? Well, profits due to payment of wages. You have to pay more wages. That's going to be the cost that you're going to be facing. And so the first order condition, we're going to take the derivative of our profit function with respect to how much labor we hire. We can then express this derivative equating the marginal cost of an additional unit of labor. If you hire one more worker, that's going to cost you W. And that additional worker, it's going to give you a marginal benefit in the form of the additional output, the additional production of that worker. And that's going to be the marginal productivity of labor. And so we know that our optimum, we want to equate the marginal cost of the worker to the marginal benefit of the worker. Put in terms of the steps of the recipe we were covering in the previous video, if you're hiring a worker and the marginal output of that worker is higher than the marginal cost, in this case the wage, then this worker, hiring it, it's generating more profits. It's generating more output than it's costing you. So you want to hire more and more workers in this case. You keep hiring workers. As you do, the marginal product of those workers is going to decrease, but the wage is kept the same. So eventually, you're going to find a worker for which hiring an additional worker isn't going to do you any good. And that's how you find your optimum. And that's the type of intuition that I'm going to be searching for, that I'm going to be asking you to get throughout the course. Okay, we'll finish with a word of caution, because sometimes there is no trade-off, and it's very important that you are aware and alert, searching for these cases. This is usually when in an exam questions as students, we can overlook these issues where the typical way things work do not apply. Okay, so these are cases where something can be just good. This is just something that you like. More of it is always good. Or is it always bad? Perhaps, the more you do it, you just like feel worse and worse and worse. Let me give an example in a moment. In either case, before we do the example, if something is good for you, you'll never stop. You'll just have more and more and more, as much of it as you can. If something is bad for you, then you just want to do none of it. The least you can do, the better for you. Now, this is an example that we're going to cover in detail in our next video, but let me give you a preview. I'm going to choose consumption and labor to maximize utility. We're going to be subject to a budget constraint and of course to a time constraint for how much leisure or labor we can have. In this case, this L is for labor. So the clear trade-off here is that more labor is costly because you don't like to work, but it lets you buy more consumption and you like consumption. And so you want to trade off these two things by balancing in your first order condition the marginal cost of labor, that's in utils, that is this term over here, with the value of the marginal benefit that you're going to get. So because you worked, you got W extra units of income that you can use for consumption, and you value that additional consumption with your marginal utility of consumption. Okay, so you want to value those two things, and the point here is going to be to find that optimal level where you're exactly balancing the cost and the benefit. We're going to discuss this way more in detail in our next video. But what if the problem had you just maximizing the utility of consumption? There is no disutility from labor. Then what do you do? Taking derivatives here is of no use because there is no trade-off. Turns out, if you work more, it doesn't cost you anything in utility. You don't really dislike working in this example. It only gives you more income, and more income gives you more consumption, and you always want to have more consumption. So the optimal solution here is just to work as much as possible and fix labor equal to uppercase H. That's going to be the total amount of hours you have to work. So this is just a simple example where by just looking at the problem, you can identify the trade-off. You can figure out that by working more, you get more income. More income is more consumption, but there is no downside to it. So you always want to work more and more and more. And if it weren't for this second constraint, the time constraint, there will be no upper bound for how much you want to work. Okay, I hope this example illustrates the issues when you're thinking about trade-offs and when you're thinking about derivatives. In our next video, we're going to be covering constraint optimization. So we're going to be going deeper into, say, the case of constraint optimization in maximization of utility. And we're going to be putting a lot of effort into interpreting our first order conditions. Thank you.